let me explain the process of decision tree construction with the training examples we consider. So, we come back to our table of examples that we had seen earlier. I have 14 examples with belonging to 2 classes. So, what I do is that in order to consider construct the decision tree, initially I consider all the 14 examples, okay. And then for each of the attributes I perform a split. For example, if you see, so there are 14 examples, out of the 14 examples 9 belong to plus class, yes class, 5 belongs to no class, and if we split on humidity, let us say there are 2 groups, high and normal, and if you count 7 examples have humidity high and 8 have humidity low. Okay. So, if we split along that and using these values of n plus and n minus, if we compute the entropy, these are the values we get. So, the gain is this much, okay, 0.985 plus 0.592 subtracted from that 0.940. So, what we do similarly for the wind we calculate, this is the gain. Similarly, for the outlook, this is the outlook, this is the gain, and temperature, this is the gain. So, we see that outlook has the highest gain. So, in order to construct the decision tree, I will first split on outlook. Okay. So, outlook equal to sunny, I have these 5 examples, overcast this, and 2 of them are plus, 3 minus. You see overcast is pure, only plus class, so it is a leaf. Okay. So, this is my new S, these 5 examples. On this I recursively split again. So, gain on humidity is this, gain on S sunny, not the full set, only on S sunny, wind is this. Humidity is highest, so I split on humidity, and I repeat the exercise for this, and I get pure leaf nodes, and this is what I get. Now, one problem that happens in this kind of classification algorithm is you get overfitting. So, if you make the training set quite small, and if there is some noise in the training set, if you get a deeper and deeper tree, your training set accuracy will keep on increasing, but test set accuracy may decrease after some time. So, x axis is height of the tree. I explain this, suppose there is a noise, this point is a noise. If I keep on splitting it, to fit that, I will have to draw few more lines to correctly get a pure leaf, and I will have a deeper tree. All right. So, to solve this problem, what one does is that you build a tree, then sometimes instead of pure node, 100% pure node, maybe 95% pure node is enough. Okay. Like maybe this much impurity you can allow and not split further. So, this means I am clipping the tree and not building it further. This process is known as pruning. There are two approaches: pre-pruning, while growing the tree you stop, or post-pruning, you grow fully then cut some branches. Which branches to cut? You do something called a cross validation. That means you take the training set error, consider the test set error and see how much error you are getting. If it is high, you stop, don't you prune that, don't build it further, grow that branch further. Otherwise, there is something called a description length. That means description length of a tree is the height of the tree plus the number of examples it misclassifies. I want to build a tree which has the minimum description length. Okay, so this is about tree pruning. I will few extensions of the basic tree algorithm. What about continuous values? Often what we do, you first discretize the continuous value into intervals, okay, by some method. Some method you discretize and then consider decided, that is the most common. Okay. I will later discuss some properties of discretization, some algorithms for discretization. Okay. Similarly, missing attributes, you take often these are the strategies. Okay. So, C 4.5 is a popular software for decision tree which uses all this strategy. Sometimes instead of the entropy, an alternate index is used called the Gini index, which is defined like this. One more extension is a regression tree. What we do here is that instead of leaves being classes, each of the leaves are some regression line. Okay. Some constant value or some constant piecewise constant function, some values R1, R2. Instead of class, they are values. So, how do I use this? So, suppose I want to fit a regression to this kind of a function, I will piecewise fit constant values, and these boundaries will be decided by the decision tree. Okay. So, this algorithm is a popular algorithm called the CART algorithm, classification and regression tree. When I cover regression later, I will cover more details of this. These are some of the advantages of decision tree. They are very fast, flexible, interpretable, you can find rules. Disadvantage, it depends very much on the training set you use. And also sometimes get less accuracy to the algorithms we will consider in our next lectures. Here is the summary of the topic of decision tree. Note that again ID3 is all this method I discussed, they are actually clubbed together in an algorithm called ID3, which is a popular decision tree algorithm. So, it is a method of learning classes classification, uses information gain, it prefers shorter tree, overfitting is an important issue, and people have used various variation extensions to different cases. So, if you are faced with an classification problem with say discrete attribute or few values, the first thing to try is a decision tree. If it does not give good accuracy, you go for other algorithms. and decision tree is implemented in most of the softwares. So, with this, these are some of the softwares which you can use to implement a decision tree. C 4.5 is a popular, Weka is a machine learning toolbox which you can use, and R has all the decision tree algorithms. With this, I close my discussion on decision tree. In our next lecture, we will go to other algorithms for classification. Thank you for today.